Okay, this is lesson 7, 8, and 710 today. We're going to look at sampling methods and misleading graphs. Okay, so get your notebook out, get a pencil, and you will need a calculator, so get that ready too. So this is a lot of vocabulary. If you use the printed notes, it'd be helpful for you when you're taking tests or lesson quizzes to have that in front of you. We're going to start off with 7, 8, which is on sampling methods. So, a population is a group of people you would like to test or survey if you have a question you want answered. But we can't always test, say you want to know what 6th grader's favorite ice cream flavor is. It's probably not reasonable to ask every single student. So you maybe want to take a sample of those students. So if you just take a part of those students and ask them what their favorite ice cream is, that's called a sample. A random sample is when you randomly select those people to survey. A convenient sample is when you take just whoever is readily available. So instead of, writing down everybody's name that's in 6th grade in a spreadsheet or something and then randomly picking people, maybe you just ask people in your 6th period class. So that would be a convenient sample, and that's not very reliable because people in your 6th period doesn't really represent the entire population. Okay, so a random sample is best if you want to know what answer or answers best represent the population. Okay, so I have 2 different sampling methods, and we're going to decide which one is better and then justify our answer. So in the first example, Maria surveys only the band students she knows personally, and she found that 84% wanted blue uniforms. John writes each band student's name on a card, and he questions those students whose name he draws, and he found 61% wanted blue. So which one is better? I hope you thought John's is random, and Maria's is convenience because she's just interviewing people she knows personally. Okay, you guys read these 2 and you decide which one is the best sampling method. You can press pause. I'm going to say what the answer is. You should test yourself and pause it and see if you know. Okay, hopefully you said Ferdinand was better. He surveyed every other swimmer, which is random, and it's called systematic, actually, because he's doing every other person. And Anna Maria only asked people in her biology class, so that's convenience. So Ferdinand's is better. All right. Next we're going to see, is there bias in the sample? So if something is not random, it's biased. And if it is random, it's not biased. So what bias is means that your answer from your survey results might not be really true. It might have a different lean to it because of the people you asked. So if it's random, then it's not biased, which would be a better representation of the population. Okay, so letter A. The mayor surveys 100 supporters at a rally about the most important issues to be addressed by the city council. So I would say that that's biased because he's only asking the supporters at a rally. You'd probably want to ask a random sampling of the city rather than just your supporters. The principal sends out questionnaires to all students to find out what kind of music students prefer. I'd say that's not biased. He's sending it out to all students and asking them a plain question, what music do you prefer? The owner of a record shop surveys only customers over the age of 18. That's biased because he's only selecting people that are over 18. D, the teacher writes the name of each student on a piece of paper and questions the names that are drawn. That's not biased, it's random. She's putting every name on there and just randomly drawing. Okay. Next is using math to verify claims. So a principal with 1,500 students estimates that about 400 students will attend a band festival on Saturday. A random sample of 25 students showed that 6 of them will attend. Determine whether the principal's estimate is likely. Okay, so we're going to do the whole student body on one side. So we'll say 400. He thinks 400 will go out of the 1,500, so part to whole. And then on the other side of the proportion, we'll put what actually happened from the survey. So in the survey, 6 out of the 25 said they would attend. Now what we're going to do is we're going to check cross products and see if these answers are relatively close. They don't need to be exact because this is an estimate. So I'm going to do 400 times 25 and write down the answer. So 400 times 25 is 10,000. And then check the other cross product, 6 times 1,500, and see what that is. And that is 9,000. Okay, so these aren't exactly the same, but they're pretty off. This one is 9,000, and this is 1,000 more. That's 10,000. So his estimate is way off. So we would say, no, his estimate is not very good. It's not a good estimate. Okay, let's look at another one. Pause the video and try this one and see if this estimate is reasonable. I will put the answer up here in a second, so you guys pause the video and try it on your own. Okay, so when I set this up, I did 250 out of 1,200 was the estimate that this many people would ask for vacation, and they surveyed, and 8 out of 40 said that they would want it. So I cross-multiplied, checked cross products, so this was 9,600, and then this here was 10,000. And these are pretty close, they're 400 off, so I'm going to do one more check to see if it's reasonable. I'm going to, this estimate that he had of 250, I'm going to pretend I don't know this, and I'm going to cross multiply. I'm going to do 1,200 times 8 and divide by 40 and see how close that is to 250. So I'll do 1,200 times 8 divided by 40, and I get 240. So that's another way to check to see if it's reasonable, and 240 employees is pretty close to 250. So I would say yes, it is a good estimate. This is a good estimate. All right, the next thing is 710, which is misleading graphs. For misleading graphs, we've talked about doing a break in a graph. So when a graph is misleading, if it's presenting information to you that's distorted, it can be misleading. So we're just going to talk about how graphs can be misleading. So in this case, there is a break in the graph, just like we did in lesson 7.6. If we do a break in a graph, we do that so it can make it easier to read, or if we have no numbers down in this lower half and then the numbers start up higher. But a broken axis can also make things look misleading. So in this one, it looks like this is double the cost of company A, but really it's only 10 cents more. And that's because of this break in the graph. So if you're doing like a bar graph or a line graph, a break in the graph can be misleading. Okay, so both of these graphs show the temperature Monday through Friday. Which graph could be misleading and why? And I want you to know that this part is kind of hard. We're just looking at it. We're exposing ourselves to it. If you don't really understand, like, is it misleading or is it not? We're just looking at it, and we're not going to be perfect at this. And if there is a question on the quiz for this, it'd be just one question, okay? So which graph could be misleading? What they say is the one on the right is misleading because it has a break in the graph. And they say that that makes it seem like the temperature changes are more extreme here. So that's one thing, but it's okay to have that break in the graph. Just realize that you need to look at the numbers and see that that could be misleading to some people if they think this is an extreme jump, which it kind of is, but they're just saying it could be misleading to some people. All right, here I have two bar graphs, and they're saying which graph could be misleading and why. So the graph B is misleading because it doesn't start at 0 and there's no break. So it starts right at 5, so it makes it seem like this is really, really, really cheap. So graph B is misleading because the vertical axis doesn't start at 0, so the differences appear greater. Okay, so you could just say the scale doesn't start at 0 on the y-axis. Okay, how could this graph be misleading? Or how could you redraw this graph so it would not be misleading? Okay, so again, they're talking about this break in the graph. They're saying that since these numbers are so close together, this big distance can be misleading, so you could redraw this without the break, and it would be not as misleading. Okay, what about this one? How could you redraw this so it's not misleading? They said draw the vertical scale here with equal spacing. See how they have this big gap right here? And then these are the same size. That's a no-no. You have to have the scale be the same width. Okay, how could you redraw this one so it would not be misleading? So it's the same thing as this break in the graph. They're saying don't have that break in the graph, so this doesn't seem like it's so far apart when it's only, 3 apart. Again, it's okay to have that. We had that in our line graphs, but it could be misleading if you're trying to present information to a consumer or somebody trying to choose, a product to buy. Okay, explain how you could redraw this one so it's not misleading. It's a no-no to start at 16. Have this be not 0. And you can't start at 16 and then go up by 8. And then go up by 6. And then go up by 8. Wait, no, that would be, never mind. You can't go up by 16 and then 8, 8, 8, 8. That's not okay. You have to have the same interval spacing. Okay, that's it for 7, 6, and 7, 8, and 7, 10. Have a good day.